Hi, this new video is concerned on the discussions and demonstrations of the practice exercise B of lesson number 2. Lesson number 2, again, is all about the fractional exponents. In the previous video, we were able to talk about how do we transform an expression with fractional exponents, or how do we simplify expressions with fractional exponents by transforming it to an expression with into a radical expression. This video right now will talk about the application of the different laws of exponents in simplifying expressions with fractional exponents. So sharing to you right now is this window containing the material I have already placed in the Kotobee reader. Okay, so this lesson has two different practice exercises, one of which um, is already covered using the previous video. The remaining practice exercise, which is practice exercise B, is now the application of the different laws of exponents in simplifying exponentiations with fractional exponents. So these items here, I already placed them in a paint application software. So I'm opening it to you right now so that we could actually place there our solutions and possible discussions, possible parts of discussions. So let's label it this one with B. And we have four items. So you have here one, and we have two, three, and then we have four. Okay. Now, when we simplify these numbers here, we need to apply the laws of exponents. The laws of exponents, which are actually discussed in lesson 1 and way before in your grade 7 and grade 8 years, are not only applicable to integral exponents. They are all applicable to any types of exponents, which also covered the fractional exponents. What we just added in this lesson is the use of the transformation as we simplify the expressions with fractional exponents. So in short, before we deal with before we will give the final result of these expressions, we need to use the laws of exponents in simplifying them. So let's start with number one. Number one is a product of a to the power of 2/3 and a to the power of negative 1/3. Okay? My advice here is not to convert them into radical expressions muna. We need to use any laws of exponents that will be applicable here. As you have noticed, the operation separating the bases of 8 is multiplication. In short, we are going to use the multiplication law of exponents. In the multiplication law of exponents, what we need to do is to copy the base and we add the exponents. Simply add the exponents. You have 2/3 plus negative 1/3. Okay? Because we have the same base. In situations wherein we don't have the same base, we may try to find ways to make them same bases. We will talk about it probably in number 3 later. So let's continue number 1. So we have the same base here, 8, and we operate the exponent. 2/3 plus 1/3 is actually 1/3. So the combined form of item number 1 is just simply 8 to the power of 1/3. Now, the goal here is not to find out the combined form, but we need to simplify. In short, we will try to solve for the value. So to solve the value for this is by converting it using the transformation law, converting it into a radical expression, wherein the base will become the radicand, the numerator of the exponent will become the exponent of the radicand, and the denominator of the exponent will become your index. In short, this is actually cube root of 8. To simplify, we all know that 8 is a perfect cube number. It is a product of 2 times 2 times 2. There are three 2's multiplied to each other to get 8. In short, 8 is a perfect cube number. So the cube root of 3 is just actually 2. So the simplified answer for number 1 is just 2. what happened here is we applied again the laws of exponents, and then after everything is combined, we actually proceeded with the transformation law, or converting the expression of with fractional exponents into a radical expression, and we further simplified. Applying the same thing with number two. So number two is actually 12 to the power of 4 thirds times 12 to the power of 2 thirds. Again, the operation separating both bases is multiplication. In short, we will use the multiplication law. This is equal to, copy the base and then add the exponent. 4 thirds plus 2 thirds. Okay, so we simply add the exponents. You have 12 to the power of 6 thirds, or simply 12 squared. But in this problem, we don't need to transform it anymore into a radical expression because the exponent is an integer, not a fraction. So simply get the, the square of 12, which is 144. And that is our answer for number two. So it doesn't necessarily mean that every time we will be using all laws, including the transformation law. We will be using them if they are needed to be used. Number three. Number three here is a fractional form wherein the numerator is 64 to the power of 3 fourths and the denominator is a plain 16. Do not jump into conclusions like, we will use here division law, sir. We may use the division law, but jumping into it immediately may give us the possibility to commit errors. My point here is this: please transform first both numerator and denominator into the same base. Okay, into the same base. Okay. 64 cannot be expressed as base 16 because 16, the square of 16 is 256, not 64. So what we can use here is base 2 or base 4. Okay, so let us use here base. I will try to use here base 4. Base, what do you want? I will show you the two possibilities, the base 4 and the base 2. So let me use first the base 2. It's up to you, huh? Base 2. 64 is actually 2 to the power of 6. Let's check. 2 times 2, 4. Times 2, 8. Times 2, 16. Times 2, 32. Times 2, 64. So there are 6 2's multiplied to each other to get 64. So 64 can be written as 2 to the power of 6. But of course, 64 here is raised to the power of 3 fourths. So don't forget about that, all over 16. Since we use 2 as base for 64, let us also use 2 as base 16 because 16 as base 2, because we can express 16 as base 2 because 16 is 2 times 2, 4 times 2, 8 times 2, 16. So there are 4 2's to get 16. In short, 16 can be written as 2 to the power of 4. Now, we have the same bases, but first apply the power rule in the numerator para sa'yo ng later. So, power rule means we are going to multiply this. So, you have 2 to the power of 6 times 3 fourths all over 2 to the power of 4. Multiplying this, we know that 6 can be written as 6 over 1. Okay, so we have here 6 times 3 is 18 over 4, or we could just simply cancel this out. 6, 4, because 4 is 2 times 2, and 6 is 3 times 2. Natanggal na yung dalawang 2. So this is further equivalent to, let me remove muna the number 4 here. Let me use another space later. So this would become equivalent to 2 to the power of 3 times 3, 9. 1 times 2 halves all over 2 to the power of 4. Yan. Next, since we have the same basis right now, instead of what happened to 64 and 16, we can now use the division law. Earlier, we used the power law. Now we can use the division law, wherein you copy the base and we subtract the exponents. 9 halves minus 4. To make it to combine them, of course, we can write 4 as over 1. So you have 9 halves minus 4 over 1. That's not 4 over 7, 4 over 1, which is also again equal to 2 raised to 9 over 2 over minus 8 over 2, which is actually later on equivalent to 2 to the power of 1 half. So 2 to the power of 1 half is the final combination of the two of the numerator and denominator. As to the final answer, express this in a form of radical expression. The answer is square root of 2. Okay. That is that is what happened when we use base 2. Okay. Let us also try number 3 as base 4. Sorry. Let me use the space here. Look at the bottom. We can express it at base 4 because 64 is 4 times 4, 16 times 4, 64. So 64 could also be expressed at base as base 4. I am presenting this so that you later on will choose which flow of processes you would like to follow. Either way, if you will just follow the protocols and the correct properties, you will get the same answer. So I'm going to pick here 4 cube all over, I mean, raised to the power of 3 fourths. All over 16 can also be expressed as base 4 because 4 times 4 is 16. So you have here 4 squared. So we have here, using power rules just like earlier, you have 4 to the power of 9 fourths all over 4 squared. You applying the division law, so you have 4 raised to 9 fourths minus 2. And then 4 to the power of 9 fourths minus, we have 2 over 1. So you have 8 over 4. So you have here 4 to the power of 1 fourth. Okay? So 4 to the power of 1 fourth can be expressed as fourth root of 4. Okay, fourth root of 4. Now, as of the moment, this is the answer when we apply this because we haven't discussed yet simplifying radical expressions. Simplifying radical expressions will be a target of unit number 3. As of the meantime, if you see that the answers may look different because we followed here base 2 and what we followed here is base 4. If you will use any of the two, I will accept both answers because they are mathematically correct. But once we reach unit number 3, when we use base 4 here in this expression, this needs to be simplified. And we will show you that this is still equal to square root of 2 on unit 3. Okay, unit 3 na po. Sige. Any of the two could be followed. It's up to you po. Now, let's proceed to number, I'm going to extend it here. Okay. Number 4. Number 4. I place here number 4. Number 3 is very lengthy. Okay. I'm just trying to show you two different methods. Number 4 is all about this item here. Okay. Now, this item may what do you call it? This item will use the power rule and the division law. Okay, but again, it's up to you which you will use. What I would prefer is to use the power law first. Why power law? Because later on you might see that it's easier to use power law than combining this. Because when you combine this using division law, take note that yes, you have the same base, but once you subtract exponent, we have the similar fractions again. It might be another problem for some of you. So apply the power law, which is to share this exponent to both. So you have here the expression 4 to the power of 1 half times 2 all over 4 to the power of 3 fourths times 2. The numerator, 1 half times 2 is 1. So the answer is 4 to the power of 1 all over. At the bottom, 3 fourths and 2, that's 3 fourths and 2. So you can simply cancel this out. and you leave 2 in the denominator. So you have here 4 to the power of 3 halves. Okay. After applying the power rule, let's apply the division rule or the division law for 1 minus 3 halves. This is same as 1 to the power of negative 1 half, because 1 is 2 halves, minus 3 halves is negative 1 half. Okay, this answer here, before transforming it into the expression with radical expression, again, I am trying to tell everyone that the transformation law, or the transformation of a expression with a fractional exponent to a radical expression, is the sixth, considered to be the sixth law. So we will apply first the fifth law, the law of negative exponent, before transforming it to the radical expression. This can be rewritten as 1 over 4 to the power of 1 half, wherein we place it at the bottom, making the exponent positive. And then this is the time wherein we can actually now change it into a radical expression. 1 over square root of 4. Square root of 4 is 2. So the answer is 1 half. Okay? Review this video from time to time, especially for items number 3 and 4, because it's very lengthy. But the processes just involves the loss of exponents, exhaust all loss of exponents first. Once all loss of exponents are exhausted, meaning nahurot na siya og apply, you then finish it with the transformation law, or transforming the expression with fractional exponent into equivalent radical expressions. And then if you can still simplify, just like what happened earlier, 1 over square root of 4. Square root of 4 can still be simplified as 2. Therefore, your final answer doesn't contain any radical expressions. Your answer is 1 half. Again, mathematics, solving mathematics, processes of understanding mathematics takes time and patience. So please do it step by step. No need to rush, especially that we are having flexible learning and you're at home. We are not in a room wherein I could tell you that finish it in 5 minutes or before the time expires. Meaning you're at home, you have the freedom to use your time. So step by step, use your time properly. As long as you will follow our protocols, you will learn definitely. That's all for this video. This is the last video for lesson number 2. We will talk about lesson number 3 on the next video. Thank you very much. Goodbye.